Hi, let's get started with working on STM32 Blue Pill. Now this video is for everyone who is coming from Arduino, who is coming from EVR, PIC microcontrollers or 8051. It is for everyone who has never used STM32 before, who has only sometimes used 8-bit microcontrollers before and now want to start experimenting on 32-bit STM32 controllers. Now this is a quick start guide. I won't say it's a detailed tutorial, but it still covers all the details on how do you get started with STM32 and with these cheap Blue Pill devices that we have cheaply available almost everywhere. And we'll also see how to download a program onto this. So let's get started. Now in this video, what we're going to do is we're going to understand, or we're going to get introduced to the STM32 Blue Pill board. Then how do we use the STM32 CubeIDE? How do we configure the clock of STM32, which is probably the most important part of this video. Then we'll create our first program. You know what it is going to be. It's a basic LED blink program. Then we'll use an ST-Link programmer to program or download the code file onto the microcontroller board, the Blue Pill board, and we'll see what are the issues that we can troubleshoot out of it. Now for the sake of this video, I want to say I am using all the cheap stuff, the easily available stuff. The STM32 Blue Pill is easily available and the ST-Link clone programmer, which is also cheaply available. I will not recommend them for beginners, but I'm showing them because most probably you might have purchased them and you want to use them. By the end of this video, I will also give my recommendations on what to use when you are starting with the STM32 programming. So let's get started. First of all, let's see what is STM32 Blue Pill. We'll work backwards. So instead of starting with the microcontroller and its architecture and what are the different families, I usually start experimenting with microcontroller first and then dwell into the other technical details about it. So that's what we'll try to do here. So some quick notes about the STM32 Blue Pill. So these are some of the basic details about the STM32 Blue Pill controller. It has got an STM32F103C86 controller. We'll see about that controller, what it is. The important thing is it has got 64 KB of flash memory and 20 KB of RAM to run your programs. Now if I go down, this is QFP package, which is actually easy to solder with hand as well, and this is what present on the Blue Pill. This is the another QFN pinout, which is difficult to hand solder, but the Blue Pill has this package. Again, more about the package and details can be seen later on. This is the interesting thing for us. So if you look at the STM32 Blue Pill board, and if you hold it this way, where the USB connector is upwards and these 4 pins are downwards, then these are all the different pins that you can use. Now some very simple tips, or the most important things are the STM32 operates on 3.3 volt. It doesn't work on 5 volt like the 8-bit microcontrollers, and it also cannot be tolerant to 5 volt input signals. Some pins are 5 volt tolerant, some pins are not 5 volt tolerant. But if you are starting up, it's better if you assume that it's not 5 volt tolerant, and then you can work backwards by checking which of them are tolerant and which of them are not 5 volt tolerant when you connect inputs to it. Now quickly taking a look at this pins, you can see we do have a number of different general purpose input output port pins. Ground connection 3.3 volt, reset connection 5 volt, ground 3.3 volt. This board can be powered on using this USB or by directly connecting 5 volt onto this pin. Now if we have to look at this closely, you will see it's having 2 LEDs, one connected as power on indication, another one is PC13. That's the typical user LED. That's what we're going to blink when we download our first program into it. These jumpers are a little bit confusing, but I would suggest if you are using Blue Pill, if this is your first time, keep the jumpers as it is, as they are shown in this picture. Don't change or don't do anything with that. We'll see about it later on. Now this is the schematic of Blue Pill. Again, I won't go into many details of it. I'll just show you these 2 LEDs are there, and then you will see it has got one 8 MHz crystal and 132.768K crystal. So this is for the microcontroller, this is for the real-time clock on controller. Now as you can see here and here, it has got several ports, PB, PA, or port A, port B, and port C. These are the 3 port pins or ports that we can observe, and you can configure each pin. Now things gets interesting when you start using it into the IDE, when you start writing program for it. Now the official ST-Link IDE is STM32 CubeIDE, which is provided free of cost by STM or ST Microelectronics. This is the quick info about the board. I'll explain you what is HSI, what is LSI, what is HSE, what is LSE, and all these things. But first, let's get started with STM32 CubeIDE. All you need to do is simply go to STM32 page or simply search for CubeIDE. You'll need an STM32 account to download the STM32 CubeIDE. When you download it and install it on your computer, you'll have to create a workspace, basically give it a folder where it can save the different projects when you start up. Now let me go for it. STM32 CubeIDE. Now it will have a project open. Let me close that first. Close project. Okay. Now what I'll do is, this is your blank STM32 CubeIDE when you start it, and what you need to do first of all is go to File, click on New, and create new STM32 project. No need to select any other things, just simply click on New STM32 project. Again, it will require connection to your ST account. Over here, MyST. It will ask you, when you open it for the first time, it will ask you to log into your MyST, and the STM32 IDE will pop up a login window as well. So the same login which you use to download the STM32 IDE from their website, you will log in with those credentials into the IDE as well, and then you can start using it. This is the target where you want to reach out to. Next step is you need to enter your part number. So the one which we are using is STM32F103C8T6. You can just select one of them and then click on next. Give a project name. Let me give it a project name. My STM Blinky. You can just give any project name as you want. And don't make any changes. Keep this to be using default location, targeted language C, targeted binary time executable, targeted project time STM32 Cube. And don't click finish, click on next here. Copy only the necessary files option over here, and now click on finish. This will create the project for you, and it will also open up the configuration window for you, where you can configure the microcontroller's port pins, which pin you want to use as input, which pin you want to use as output, or any kind of changes that you want to do over there, and you can start writing program for it. So the next window coming should be over here. This is the LQFP48 package which we have on our Bluepill. As you can see, all the port pins are shown over here. And let me go back to the presentation for a moment. We have an LED connected to PC13. Can you find PC13 over here? This is the PC13 or PC13 LED. Now we need to use this pin and we need to blink this pin. So let me just go to the STM32 IDE and let me choose PC13. Okay. So this is PC13. Simply single click onto it. Okay. Single click, GPIO output. I want to use it as GPIO output. That's it. Next one need to do is look at these different options over here. System core, analog, timers. For now, we don't want to go into any of these options. Okay, just go to system core. This RCC, this is important. This RCC. Why this is important? I'll tell you. Now let me go back over here. There are different clock sources into STM32 architecture, and they are named like that. So HSI, LSI, HSE, LSE. HSI is basically internal clock. LSI is also internal clock. This is a high speed internal clock, this is a low speed internal clock, and this is high speed external clock, and this is low speed external clock. So you have option to either use the internal clock source or external clock source. Simple. The nomenclature is not difficult to understand. So if you go to RCC over here, then you need to select this HSE because we are using the external crystal. So just simply go here and use crystal/ceramic resonator and get back to our configuration. So GPIO we have selected, RCC we have selected. This is in the pinout and configuration. The next thing to do is go to clock configuration. I don't want this to be scaring you, but remember what we have, as I said, is either HSE or HSI. The HSI or high speed internal clock is fixed 8 MHz. HSE is an external crystal. You can connect an external crystal over here. And then you can use an internal PLL multiplier to multiply it because it's a high performance microcontroller. You just don't want it to be operated at 8 MHz. But if an external crystal like 50 Hz, 60 Hz, 70 Hz, like that is used, then it leads to a very greater power consumption. So most microcontrollers have an internal clock multiplier. So it simply takes clock externally and then multiplies it internally to achieve a higher clock rate. Now we need to select one of these two options, which clock you are using. Right now in the configuration we have selected high speed external clock. So just use this over here as a source to this PLL, and now same thing goes over here. So this is system clock, it should be HSC or it should be PLL clock. I want it to be multiplied from PLL, so I select PLL clock. If you select over here, then 8 MHz is directly going to everywhere else. Don't just ignore all this part for now. Just focus on these two things. HSI, HSC, PLL clock. So here I'll give the external high speed clock to PLL, and then to all the systems we'll give PLL clock. So one option over here, one option over here. Now what should be the settings? Okay, we want the maximum performance, we want the maximum speed that we can have. So simply go here and type 72 and hit enter. That's all. If you have everything done correctly, if you have everything done correctly in pin configuration, going to RCC, if external resonator is selected, if you go to clock configuration, then this HSC will be enabled. The problem happens when you have not selected this over here, and if you go to clock configuration, then what happens is HSC option will not be available. As you can see, you can only have HSI as an option going to input as PLL, and over here also you can have PLL clock, but it will only be multiplied to the internal high speed clock or 8 MHz oscillator. So if you want to, and it will not give you 72 MHz the maximum clock. So make sure go to pinout and configuration, go to high speed clock and crystal ceramic resonator, and then you go to clock configuration. Now you can select HSE, here PLL clock and 72 MHz max frequency. This is it. Nothing else is required. Now all you need to do is simply generate your code. Now there is a very small option over here which is very difficult to find many a times, but you can simply go to the project option and generate code. That's the symbol over here if you can find, but I prefer going to project and generate code. Just click yes to this window, and now you'll see a whole program is created. Now if you look at this program, it may find a little bit scary to you at first, and as I said, we'll not go into all of these details in the very first video. This is your getting started one. You just want to get your first program downloaded, and then you can explore everything later on. So just understand that the PC13 pin that is selected to be used as output pin, everything related to it, all the background calculations or all the background configurations of making that port work as output and all those things are taken care for you. All you simply need to do over here is go to the while one and enter your code where you want to blink that port pin. Now let's get started and let's write those simple 2 lines of codes. So what you need to do here is simply write down HAL, just write down HAL underscore GPIO. You can also do control space to see all the options. So HAL GPIO underscore write pin. That's the function call. Now if you just, let me do it again. If you select that function call, it gives you the format. So it makes it easier for you to use this function. HAL underscore GPIO underscore write pin. At this point, you just have to hit enter. Now it says what you want to write on. GPIO X. It means which is your GPIO port. So ours is GPIO port C, GPIO C. Then GPIO pin. So over here you need to write GPIO underscore pin underscore 13. And then what is the pin state that you want to achieve? So the pin state you have to achieve over here is GPIO underscore pin underscore set. Set is making that pin go high. That's it. Again, we need to add some delay. So HAL underscore and enter your delay, expected delay in milliseconds over here. Let me have 1500. Now you know what you need to do. So you simply have to copy this line and paste it over here. This time we will not set the pin, but we will simply reset the pin. That is, the pin will become 0. So set for 1.5 second, reset for 1.5 second. That's our first Blinky code. Once the code is written, just go to project and build all. I just want to build it. That's it. So I have 3 errors. Let me see what they are. GPIO pin 13 is undeclared. Okay. Let me see what's the issue over here. So GPIO C, GPIO underscore pin underscore 13. PIN. Everyone will do this mistake one time or another. If you go to the folder STM32 My Blinky, right click that, show in System Explorer. So if you go into System Explorer, this was my project, my STM32 Blinky. Then there will be a folder called debug, and here you will find this ELF file, which is something that you can download onto your board. So this is the file we'll use to download. Now to download this program onto the STM32 Blue Pill, we'll need an STM32 Cube programmer. You'll have to download it again from ST's website, log in and download this onto your system. And then you'll need an STM32 programmer, the hardware part of it. So it is ST-Link programmer. There are a number of cheap alternatives available, just like this one, and I have exactly the similar one. Okay, they are not perfect, they are not even say very good, but they get the job done. And this video is about understanding how to download the program file using this programmer as well. So let's see how do we do that. Now to download it, all you need to do is you need to connect the ST-Link programmer to your Bluepill. So this is my STM32 Blue Pill. These are the 4 pins I have as shown over here. I have made the connections according to the diagram you can see over here. So this is my ST-Link programmer. Again, as I said, the cheap one, my casing has been gone off. This is my ST-Link Bluepill program, Bluepill controller board. Now, if you have made the connections correctly, just connect it to your computer and you will see the ST-Link being turned on. Right. Now the connection to computer is over here, if you can see, using my USB hub. Now let's go to the CubeIDE, nothing else to be done over here. Remember, with this kind of cheap ST-Link programmer, you can only download the program. You cannot do debugging, you cannot do live program debugging, okay? Just simply downloading the code. Now to do that, open the STM32 Cube programmer. Once you install the Cube programmer, don't try to connect. Simply go to open file and open your project file. So my project was my STM Blinky, debug, and this elf file. Opened it. Ideally, what should happen is I should be able to click this button and connect it and then download the program. But it just doesn't work like that. So if I click connect, you'll see no STM32 target found. Why that happens is because these cheap programmers do not reset the blue pill correctly. They just don't reset it correctly, and that's why it doesn't go into the programming mode. It doesn't go into the mode where it can download program into the IC. Now, what is the workaround? You will see number of different blogs and tutorials saying number of different things. Some of them will work, some of them will not work. What I'm going to show will work 100%, and that is there is a reset button over here. Okay, what you need to do is you need to keep that reset button pressed. You'll see, let me just show you over here. So I have pressed it now. Keep that reset button pressed and now go to STM32 programmer and then click connect, and after you click connect, leave that button. As you see, data read successfully. Now you can download your program by clicking on download. My file download is completed. My LED now should blink with 1.5 second delay. Let me reset that, and you will see the PC13 starts blinking with 1.5 second delay. Let's try to make a change. Let's go to CubeIDE and let's make it 500 instead of 1500. Project, build all. Let's go to Cube Programmer. Let me close this file and let me open that again over here, or you can also open file over here. My STM Blinky. Again, if I click connect, nothing's gonna happen and it will throw you number of different errors. If what you need to do is keep the reset pressed, click connect. Now even if you delay, it gets connected, and download. The code is downloaded. Now I'll press the reset button. As you can see, the LED is now blinking with a 500 millisecond delay. This is how you start your journey with STM32. This is how you download your first program into STM32. In the most ideal way, you should not use these blue pill boards because they are quite cheap, and you might end up spending, I don't know how many, countless number of hours trying to get them working. So it's always better to go for STM32 discovery boards or STM32 Nucleo boards. The thing with these boards is they do have their own programmer onto it, and you don't face any such challenges or issues when you download your program onto it. We'll see that as well in a separate video. I know the video went a bit longer than expected, but I think I have covered all the basic things that are important. Thank you.